Concepts surrounding time have always fascinated and baffled people of all ages, even the greatest of minds. Be it in books, movies, or even real-life magic tricks or illusions, time has basically become a theme that is continually played around with. Time manipulation, reality reversal, time travel, and even teleportation, which is basically moving matter through space and time. In this video, I will be demonstrating practical ways to visualize how gravity affects time, which is a phenomenon known as gravitational time dilation, or simply, time dilation. Indeed, time dilation touches into Albert Einstein's general theory of relativity, which will definitely be way too long to get into for this short of a time. And that's actually quite ironic since we're talking about time dilation. After all, dilation, or to dilate, literally means to expand or extend. Perhaps some of you have already known this for quite some time, but over the years, we've seen applications of this concept on screen. There's Superman's gravity gun with a very brief explanation of this idea from an enlightened Lex Luthor, who states,
"Gravity warps time."
The gravity gun sped up his clock a little.
And then you have Christopher Nolan's fairly recent Interstellar, which also dwells on black holes and more dimensions from what we all know. Bear in mind that we live in 4 dimensions, 3 space coordinates, and 1 time coordinate. So Interstellar basically shows us how great gravitation affects time.
Well, every hour we spend on that planet will be 7 years back on Earth.
By the time our protagonists get back onto their ship, the Endurance, they are shocked to find that the 23 Earth years had already passed for their friend who had stayed put. How does that work? Suppose this line represents the 23 years mentioned, and then you have this rubber band as the minutes or hours our protagonists spent on the planet. As mentioned earlier, dilating is to expand, and so though they do not feel it, time is literally stretched, matching the 23 Earth years where they experience through mere minutes. In case that still left you quite confused, I'll take a more direct example. Light, specifically the speed of light. We're all too familiar with the most basic speed equation, that is, speed is equal to distance over time. We also know that the speed of light is constant, meaning if one of the variables on the other side were to change, the last variable remaining would also have to show the same amount of change to keep speed constant. Take these 2 rubber bands. They both represent the speed of light, but as you might have already guessed at this point, gravity bends light. Speed doesn't change, but getting from point A to point B is extra distance, and in turn, takes longer. Remember, it's all a matter of relativity.